The time has arrived, my friend, where we get to apply our skills regarding access control list for the purpose of packet filtering to our production network. So here are the requirements that have been asked of us. Let's walk through them, make sure we're clear on what they are, and then we'll go to the lab and implement and verify them. So here's what we've been asked to do. On the Core 1 multi-layer switch, regarding its logical Layer 3 VLAN 10 interface, which is supporting VLAN 10 at the moment as far as their default gateway, here's what they want us to do. They want us to permit TCP traffic from VLAN 10. This is the 10.16.0.0 address space to anywhere if the destination TCP port equals 80. All right, task number 1, got it. Task number 2, or line number 2, permit PC10 to ping R200. Let's verify where that is. So here's R2, there's 00. That's on the Metro Ethernet network. So that address would be 10.16.7. And R2 is using .6. So we'd want to permit ICMP traffic from that specific host, PC10, to this IP address 10.16.7.6, and have that in the access control list applied to the VLAN 10 interface on Core 1. All right, that's number 2. Great. Number 3, they want us to deny VLAN 10 to ping the Metro Ethernet. Now this is important to understand because we just had a requirement for a single host on this subnet to ping a device on the Metro Ethernet network, and they're also asking us to deny everything else. So the order we place these in is important because the router is going to process them from top down, and when it finds a match, it's going to execute with either a permit or deny, and it's not going to continue checking. So if we're going to permit PC10 to ping this interface, that permit statement needs to go before we start denying everybody on this VLAN 10 from being able to ping anywhere on this Metro Ethernet space, which is 10.16.7.0 with a 28-bit mask. And that's right here. So that's entry number 3. Great. And then deny all TCP traffic from VLAN 10. So up here, it had permit TCP traffic from VLAN 10 if it was port 80. So this statement is then saying we're going to deny everything else. So if there's a match on line 1 here, or this first entry, that traffic will flow, but anything else will be denied based on this one right here. And then the final entry is going to be permit all other traffic. So here's what I invite you and encourage to do as we apply this. I would encourage you to watch this video and get ready to pause. And what we'll do is we'll step through it piece by piece by piece, and then we'll go back and verify it. And after you've watched it once or twice, I would then encourage you to break out the hands-on lab and go alongside me and implement it and configure it and verify it as we go through it together. So having said that, let's go to Core 1. We'll create the access list based on the requirements, and then we'll apply it to the logical interface called VLAN 10, which is a switch virtual interface on Core 1. So here on our management computer, we'll open up PuTTY, and we'll launch a console over to the multi-layer switch Core 1. So for the access control list, the one we're going to choose is going to be an extended ACL because we're going to have to match on more than just a source IP address. There were requirements in there regarding layer 4 protocols like TCP and destination ports and destination IP addresses, which all scream out, hey, use the extended ACL. So we could use a plain old numbered ACL or a named ACL. The choice is yours. For the demonstration, let's go into configuration mode and let's create a named ACL. And the first one says to permit. So we're going to go ahead and do a permit. And it's TCP, and we're going to permit traffic from VLAN 10. So the source is going to be the address space of 10.16.0.0 with a 24-bit mask. So the wildcard associated with a 24-bit mask would be 0.0.0.255 space. And for the destination, it said regardless of where it's going to as far as the IP address. So we'll use the keyword of any to mean we don't care about which destination IP address it's going to, but we do care about the destination port has to be equal to, so we use the keyword EQ space 80 based on the requirements and press enter. We now have our first entry in our named extended access control list. For the second task, it's permit PC10 to ping R2's 00 address. So we'll do a permit and we'll do ICMP. And ICMP will cover the ping. We also could get more granular in specifying what attributes regarding ICMP and the ping that we're going to permit. And the request was for the actual individual host at 10.16.0.10 and going to R200 address. So we'll do host 10.16.7.5. So that permit statement is enough for a ping to be successful between PC10 on the VLAN 10 network and that gig 00 interface on router 2. And wait a sec. Let me take a look at my notes real quick. That's the wrong address. All right, so R2, if we look at R2, it is .6. So we've got to put the right IP address if we want it to work correctly. So I'm going to remedy that, and here's how we remedy that. We go ahead and hit the up arrow key one time to bring up that previous command, a Control A to put the cursor all the way to the left, type in no, space, and press enter. And then just to be sure, I'm going to do show access list, just to make sure that what we think we put in is already there. So currently we have the one entry, that's great. And if we hit the up arrow key a few times, let's go ahead and put that correct destination address of 6. And then I'll hit the up arrow key a couple times, and we'll do a show access list, the list. And that will filter the output just for the access list that we're currently creating. So our second line is permit ICMP from the host 10.16.0.10 to the host 10.16.7.6, which is the correct IP address. Great. On to the third line. Now it's important to note that PC10 will be able to ping this interface right there, because as the router processes the access list top down, it's going to go ahead and match on this one first for PC10's benefit for the ping before it would get to the deny. And if these were flipped in the reverse order, when PC10 tried to ping anywhere on the Metro Ethernet, it would be denied. So we need to be conscious about which order the entries are placed in the access control list. So let's do the deny VLAN 10 regarding getting to the Metro Ethernet network. So back at the CLI, we'll do a deny, and we'll do ICMP, which will cover ping, and we need to specify the source, which is VLAN 10, which is 10.16.0.0. It's a 24-bit network, so our wildcard mask would be this. And then the destination is that Metro Ethernet network. So the Metro Ethernet network is 10.16.7.0 with a 28-bit mask. So what would be the network? Well, we'd put here 10.16.7.0. That's the network. And then for the wildcard mask, we'd care about the first octet matching, and the second octet, and the third octet. That brings us up to 24, but the last octet is 4 bits on for networking there. So if we did this, 128, 64, 32, 16, 8, 4, 2, and 1. And let's go ahead, and this is the 24-bit boundary right here. And our mask, which I'll put in black, is for a 28-bit network. So there's 25, 26, 27, 28, and there's the dividing line. So this way is network, and over here we have hosts. So for the matching purposes, we care about everything to the left of this line. So then for the wildcard bits, which is like an inverted mask, we have 0, 0, 0, 0, 1, 1, 1, 1, and we simply add up those bits that are on the wildcard mask. So we have 8 plus 4 plus 2 plus 1, which is 15. So we'd have a 15 here in this last octet for the wildcard bits, which means we don't care about matching in the last 4 bits of this network of 10.16.7.0 because those last 4 bits are host bits, and they could be anything. So we'll put in the network of 10.16.7.0, that's the network, and for the wildcard we'll have 0, 0, 0, dot, and for the last octet we'll have 15. So deny ICMP from the 10.16 network if it's going to the 10.16.7 network with the associated masks and wildcard bits that reflect that, and we'll press enter, and that's our third entry. And then the next one says deny all TCP traffic from VLAN 10. Okay, so what we'll do is we'll do a deny TCP, and VLAN 10 is still right here, so I'll just take that and copy paste it. And regarding the destination, it said anywhere, so we'll put the keyword of any, press enter, and that's going to deny, and that row is going to deny TCP traffic source from 10.16.0 going anywhere if it tries to come in that interface, the VLAN 10 interface on the multilayer switch. And then the last statement is to permit everything else. So we'll do a permit IP, which refers to the entire TCP IP protocol suite for IPv4, space, any for source and destination. And we are done. Well, at least we've created the access control list. Now let's go ahead and verify it. So I'm going to use the up arrow key a few times and do the command show access-list space and the name of our list, press enter. So now that we've created the access control list, let's apply this to the VLAN 10 interface on our multilayer switch. And to do that, we'll go into interface VLAN 10, and we'll use the same command we did on a normal router, which is IP access group, the name of the access list, which is the list, space, and then we'll apply that inbound and press enter. Then if we do a show IP interface for VLAN 10, referring to the logical layer 3 switch virtual interface on this multilayer switch, it's going to show us, among other things, that the inbound access list is currently set. It is the list, which is what we just created. So this switch virtual interface is the one that's supporting VLAN 10. where the access control list is now applied. So now from PC10, which is in VLAN 10, what should PC10 be able to do? PC10 should be able to get to a web server on port 80. And we've got a web server at 192.168.1.100 that we can try. Great. We should be able to ping this interface on R2, which is 10.16.7.6. And what PC10 should not be able to do, because it's on VLAN 10, it should not be able to ping the other interfaces on the Metro Ethernet. So it should not be able to ping 10.16.7.5 over here, nor should it be able to ping 10.16.7.7, which is R3 on that Metro Ethernet. And any other type of TCP traffic coming from VLAN 10 should be denied. So this PC should not be able to go to an FTP server at that same IP address. That should be blocked. And then everything that wasn't previously matched in this access control list, which is trying to go in through the VLAN 10 interface on Core 1, should be permitted if it wasn't matched previously. So let's test that. So to test this, we'll go to our client machine. And on our client, let's open up a command prompt. One thing we should be able to do is open up a web browser to a server, and that should be permitted by the ACL. So we'll open up Chrome. And let's go to 192.168.1. And 100. Perfect. Press enter. Great. That does work. All right. That's our first entry in the access control list that's permitting that. Fantastic. I'll go ahead and actually close that. Next, we should be able to ping R2's interface that's connected to the Metro Ethernet. So let's try that. We'll do a ping to 10.16.7.6. Press enter. And that does work. But what we should not be able to do is we should not be able to ping .5 or .7, which are the other two router interfaces on that Metro Ethernet network. So let's go ahead and try .5. Yeah, that's great. Destination network unreachable. That's because our multi-layer switch with its interface VLAN 10 is sending a message back saying, yep, I killed your packet. So we'll hit the up arrow key and we'll try .7, which is R3. That also is failing. Fantastic. And then we also should not be able to use FTP. Yeah, so if we do FTP out to 192.168.1.100, press enter. And it's just not going to connect. It's going to time out. So I've got a question for you. How do we go about verifying in real terms that the access control list that was permitting or denying was actually doing the permitting or denying? How do we do that? Now, if you're saying, Keith, I know. We just go back to the CLI. We do a show access list, and it will show us the head counts. That is spot on. Let's go back to Core 1 and take a look. So back on Core 1, let's do a show access lists. And if you want to tag on the name of the ACL, you can as well. Or you can just pick it from the list. And actually, here it is. So here is our access list. And check it out. For the first line, we have 15 matches. The second, we have 4. Now, when you do this lab, your mileage is going to vary a little bit based on the number of matches, based on how many times you retried to do something, and how many times that packet was either permitted or denied. And the great news is that for each and every one of these lines in our access control list that we recently created and applied, we have hit counts, implying that those were matches that were done by the access control list that then, as a result, permitted or dropped that traffic. So I've had a lot of fun in joining you in this lab where we've taken the concept of a packet filtering access control list and applying it to an interface in a production environment and then verifying that it works. So I'll see you, my friend, in the very next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.